in this problem, we're solving for the max range of a projectile going out when we know the maximum height of that and we know the magnitude. So this is almost exactly opposite from the problem that we worked before, but we will give it a shot and see what we can do. We are given the magnitude and we're giving y max. So how do you go from there to r and theta? Well, if we remember the equations that we had before, what we derived in the last problem, we can know that there is an equation that has these variables in it. And with that, we only have one known, so we'll use that equation. If you want reference to the derivation of those equations, look back at the last video. But the equation that I'm referring to is v of y squared equals vy naught squared minus 2g, let's move this down, 2g y max minus y naught. And this is a nice equation because it has v in terms of y with no time. So that is always what I'm looking for, is there time or is there not time? Once again, if you had wanted, you could have solved for the time and plugged the time in here and then gone for this way, but we've already taken off some of the extra work by pre-plugging those in, and then we get this nice equation here. So if you're really feeling lost, just solve for time and then you can find out exactly what you need to, but it's always a good idea to learn these little tricks because it will save you time on an exam. So we know that this is 0, and this is broken up into the magnitude, which is v naught, and the direction, which is sine theta, because we are looking for the vertical component of that velocity. Then we get negative 2g, which is the, we're working in meters, so 9.81 meters per second. Then y max, which is 5 feet, minus 0. Once you solve for that in your solving of choice, whatever we want to use, MATLAB, Mathematica, then you get, and I said that exactly backwards. We are looking for that. We know the magnitude, and we're looking for theta. So solve for the actual unknown that you're looking for, and you'll find that that theta is 23.3. So now this moves to the other side, and all we need to find is r. Now I want to talk about r because it is similar to the problem that we derived last time and that we just used now, which is v in terms of y. What was unique about v in terms of y is it came from v in terms of t and y in terms of t. They're plugged into each other, so then you get an equations like this. Unfortunately, if we were to look for v in terms of x, you can't do that same thing because x, or v of x, is in terms of v of x. In this case, because once again, we're just looking at vertical acceleration due to gravity. But you do have x in terms of time. So there's no way that you can do this because there's no acceleration there. If, once again, there was a rocket on your projectile motion and you get acceleration due to a rocket, then you could do that, but that's not the case here, so there must be another solution that we can do. Like I said before, if you're lost, solve for time. Well, we did that before, and we pretended to solve for this time and plug it in here. Well, time is the same in all of the problems that we're doing. It doesn't change. So we can do this. And we can have these substitutions, and that'll give us information about what's actually going on. Or we could do this, and we get the velocity in x. So instead of y in terms of x, we get velocity in terms of x. And since we have up here that we're looking for x, this is x, in terms of velocity, which is what we have, or we could do y, we can have that equation either way that we want it. And the reason why we can have that equation either way that we want it is because of this variable time. But because range is typically written as an equation of x in terms of v, that will be the substitution that we make. So let's go through that real quick. And this is just like the other one where we used a time variable in between to solve for the equation of choice. So this is range. And you'll see that word everywhere. And it is r in terms of v, which is f, or x in terms of v. So to get that, we will write out the equation that we derived in the last video. So if you want that, just let me know. And not let me know. Click on the link. There's the link for the other one. Then we also use the y equation, which is vy naught t minus 1/2 gt squared. And we use t as the go-between to solve for it. And let's simplify this equation just a little bit, because in a range problem, the y's are equal to each other. Even if you're super high, super low, range problem is always when y naught equals y final. So, with these equaling 0 and canceling out the t's, then you get v naught sine theta equals 1/2 gt. So this and this, we will plug those into each other, and we get v naught sine theta equals 1/2 g times r v naught cosine theta. So that's plugging t in for t. Then if you pull r to one side, then you get 2v naught squared sine theta cosine theta all over g. So that is your range equation. Now if you really felt like simplifying this even more, you can, because there's a trig identity that simplifies this down. And thankfully other people before me found that. And that is r in terms of v equals v naught squared sine 2 theta all over g. So this is our nice new equation. So far, we have acceleration from the sum of the forces. We have velocity in y in terms of time. We have y in terms of time. We have x in terms of time. Then we also have y in terms of v, or v in terms of y, whichever way you want to say it. And now we solve for range, which is x in terms of v, or if you wanted to resolve for v naught, then you get v in terms of x. So those are all really helpful equations, and I'm sure over the next few weeks when you work a million problems, you'll get very, very familiar with them. But going back to this very specific problem, when you plug in what we know about our problem, you get sine 2 times 23.3 all over 9.81. And when we solve for that, that is r equals 46.4 meters. So we have now officially solved for everything we need. And I'm going to continue posting videos up here. They'll be pretty sporadic, so if you want to subscribe, you'll get updates on when the actual videos go up. And then I'm going to be putting these videos in individual playlists for each homework set. So just keep in mind that all these videos are on here. I'm not really going to update Canvas as much anymore, because I think most people have found their way to this channel, and it's a lot easier to only have to update one place at a time. So let me know if you have any questions, and leave comments down below if you have any questions too, because if I answer your question, most likely there was someone else who had it, and I'll probably post questions over there that I get over email. So you can also email me as well. I'll just probably post the answer here.